parking fee problem, we talked about that that's called a piecewise function, because basically it's a function that's in pieces, and you have to write which piece goes to which part, which is that domain part that we just put out there. So your graph is in pieces, your domain is restricted, and you just have to practice, how do I graph this? What do I mean? What does it look like? And so we're just going to practice doing that. Right? So we're going to start with just look at this one. It has 3 pieces of the graph, which looks really scary. And what happens every year in Algebra II when we teach piecewise functions, it looks scary, and so people just like don't want to try it. It's really not that bad. And if you think about what we talked about with the parking fees yesterday, like this is one equation, but you only do it when x is less than -2. This is another equation, but you only do it between -2 and 6. And this is a third equation, but you only do it greater than 6. And notice, it almost always happens like this, where one stops and then there's starts, right? So this one only goes less than -2, this one starts right on the other side of 6, and then it starts on the other side. So if they ask you to evaluate a number, you only look at which part is in that domain. So this is function notation. It says f of -4. Which section, the first, second, or third, would x equaling -4 be part of? Would it be part of x is less than -2, between -2 and 6, or greater than 6? Because -4 is less than -2. You see that? So for f of -4, you don't look at any of this. You only look at this top equation, which is just the equation 5. Right? What does that equation look like if you just had y equals 5? Like on a graph. Where 5 on the y-axis all the way across. It's just a horizontal line. So at every point, do you agree that the y is just 5? So when x is -4, do you agree that the y is just going to be 5? It's nothing to do with these two, because -4 only applies to that section of the graph. So look at this one. If I said f of 8, which segment, top, middle, or bottom, does 8 fall in the domain? If it's greater than 6, 8 is greater than 6. So for this one, I only look at this segment. And if I was going to do f of 8, what does that mean to do again? You just plug it in for x. Here there was no x to plug in, which is why it was just 5. But here I would say -2 times 8 plus 10. And I know it goes there because 8 is bigger than 6. And I need to work it out, right? You probably would just do that in your head. -16 plus 10, you would say it is -6. And the last one, oh, what about this one? -2. Right, so this one, so we have everything less than -2 here. Here's everything greater than or equal to -2. So although -2 is listed twice, it's only included in the middle one. So I'm going to plug -2 in only for this middle one. And I'm going to do 1/2 times -2 minus 6. Half of -2 is -1 minus 6 is -7. So if you just understand which piece you're using, you just plug those in. So you don't get 3 answers for each one, you just get 1 answer. Questions about that? So you have a couple questions on your homework like this where you're just practicing knowing which part to use. But the big thing we want to be able to do is we want to graph these. Okay, so I'm going to start easy here. Start with 2 pieces, and then we'll graph these. So it says graph and give the domain and range. Again, we always just put the little bracket there to show the pieces. This tells us where we're starting and stopping. So you don't have to do this, but here's my suggestion. This tells me where each piece of my graph is going to be. So what I think you should do is kind of divide your graph up into 2 pieces. So where x is 3, which would be over here, I'm going to make a little dotted line on my graph just to kind of show me that that's where the pieces split. So at 3, I'm just going to make a dotted line. Remember when you graph, a dotted line means it's not really there. Kind of just to help us. Where's the domain changes, which is at 3. That's how I knew to put it at 3. And then I have to know how to graph. You can make an XY chart, but hopefully when you see x minus 1, you think of good old y equals mx plus b, and you're just going to graph that line. And then we'll talk about in a minute what this part means. So if I'm going to graph x minus 1, my y-intercept is -1, right? That's my y-intercept. So on the y-axis, I'm going to go down here to -1. And then I'm going to do my slope. My slope is the number in front of x. What's my slope on this one? Well, I'm going to go up 1, over 1, up 1, over 1. And don't make your line yet. So it's still the same way we've always graphed. The only difference is it tells us we can only graph it to the left of that line because it's less than or equal to that line that we drew in. So we're only going to graph it on this side. So I always go to my dotted line. So I'm going to go up 1, over 1 more time. And then it's either going to be a solid circle or an open circle based on this right here, right? So because it's less than or equal to, I could make a filled in circle right there. And I'm not going to go anywhere past it because I can only go less than. So I'm going to just connect the line, put an arrow on it to show that it would keep going in that direction. So I've kind of just cut off this part of the graph. Questions on how I got that? Okay. Then I just do the other half on the same graph, just like on our parking fees where we had two things going on the same graph. This one's just a number. And remember what Alex said. Remind us again, Alex. What does it mean when it's just a number and no x in the problem? Where do I plug it? At the y, right? That's like your y-intercept, and it's just a slope of 0 because there's no x. But it's only greater than 3. So you have two options. One option is you could come over here to -1, and you could imagine drawing it over here, right? But you can't start it till right here. The other option is I always just started at my dotted line. So it's still going to be where y is -1, but I can only start it right here at 3. And notice I'm making an open circle. Why am I making an open circle? Because it's not included, right? And then it's just a slope of 0. So it would be going in this direction. Because right here it just says greater than 3 on the x-axis, right here. I don't understand the question. No, everything after it is included, right? Just the 3 itself is not included. All of these are included. Here's an easy way to check if this is even a reasonable graph. This should still be a function, which means it should still pass the vertical line test. So we always have like one graph on one side, one graph on the other side. The line where they meet up should never have two filled in circles, right? Because if this one's filled in and this one's open, it still passes the vertical line test. So if you ever graph this and you have like overlapping things, then you've done something wrong because it should always work. So here's the fun part. Domain and range of this. Every domain we've had so far has been what? Negative infinity to infinity, all real numbers. These, for the most part, should have a domain of all real numbers too, and here's how you can know. If one starts where the other one stops, and they go in both directions, then all the x's are still used, right? Because this one starts at 3 and goes to the left forever. This one starts in 3 and goes to the right forever. So do you agree all the x's are still used? The only time the domain would not be all real numbers is if for some reason these did not start and stop at the same point. Like if this stopped at 3 and this started at 5, we're missing those numbers in between. Almost always they meet up, but not always. Now the range can be a little bit trickier on these because you have to think about which y values are included. You have one going forever in one direction. What's the biggest or smallest y value that I have on here? So, anybody have any thoughts about the range on this one? Chandler, what do you think? What? Anybody agree or disagree with that? So, negative infinity I definitely agree with, because you agree that this one's going down forever, so all those negative y values are going to get used. And it goes up, but is there any y values after where y is 2, right? Here's where y is 2. Is there anything above that used? So, I think that that's the right range. What's happening over here? What's the range of just this line right here? -1, right? We did another one with 5 on it. So, like, this one, -1 is already included in this, so, like, this one is just extra. Like, there's nothing extra to add there. But just know that sometimes the ranges on these kind of, like, skip spots, and so they can get kind of weird. So hopefully by graphing these, 1, you're going to get some more practice at reviewing how to graph. 2, you're going to get better at thinking about domain and range, because this kind of talks about domain, and then you definitely have to look at it to do range. So let's do one more together, and then I'm going to give you some. Honestly, this is probably the worst that you're going to see. As there's an extra credit, I'm not going to give you one that has more than 3 years. But it's the same idea. There's just now 3 sections of my graph. I'm going to 2 sections. So again, the first thing that I do is I look at this part. This part tells me where I'm going to break up the sections in my graph. Now I'm just going to have 2 dotted lines, because it's going to break at -1, and then it's also going to break at 1. So this is going to have a really small section in the middle, but at x equals -1, I'm going to make a little dotted line. And at x equals 1, I'm going to make a little dotted line. This is where I would probably recommend graphing in pencil, because sometimes you might take a point on the part that you don't need to, and this will make it like those. But, you know, it can be a great feature in graphic things. So you can really start wherever you want. It just makes sure that you look where the boundaries are. So like x plus 3, that's just slope-intercept form, but we're only graphing it less than or equal to -1. So that would be only on this section of my graph, right? And then we're going to graph 2x, which is also in slope-intercept form. If you wanted to, you can think about putting a plus 0 next to that. You're only going to graph this in this teeny little section in the middle, and then you're going to graph 4 on the other side of that, because that's greater than or equal to 1. So, I'm going to start with the 4, because it's easier, right? 4 is just a number. It's just going to be a horizontal line at y equals 4. Can I make my dot? Don't follow me here, because I can erase easier than you if you're in 10. I can't make the dot right there, right? Because I can only do greater than or equal to 1. So I'm going to go over here, and I'm going to make my dot. I'm up at 4. I'm starting where x equals 1. And I have a slope of 0. So I know that part of my graph is 4. It's only when x is greater than or equal to 1. Yes. I just started here first. I didn't want you to mess up if you... What about the middle section? The middle section, 2x with nothing there. What's my y-intercept? 0. And then my slope is 2, so I could go up 2 over 1, but I'm not including those dotted lines. So if I go up 2 over 1, I need to make an open circle there, right? And I always make sure that I go to both lines. So I'm also going to go, instead of up 2 over 1, I'm going to go down to back -1, right? And that would get me back to that other line. And that's also going to be an open circle. So for the line 2x that normally goes all the way through the graph, I'm just graphing this very teeny tiny little section right there. I kind of missed my mark in the middle. But. So it's called a piecewise function because we're just graphing this little piece of that and this piece of this. And then over here I have x plus 3. So I'm going to give you 2 ways to do this, all right? The way that I always used to teach this is I said use pencil. and just graph it the way you always have. Go up to your y-intercept of 3, and then do your slope, but you want to go backwards, so instead of going up 1 over 1, I would go down 1, back 1, down 1, back 1, right? And I'm going to get that line, and then just go back and erase what you don't need. Totally works. Then someone, a student, I wish I would write down the names of the students that come up with these things that I change the way I teach because of it, but a student said to me once, why would you start over here, especially if like your line was way over here? Why would you do that when you could just start at the point that the line that you're starting at? Like start at -1. So they said, instead of thinking about the slope-intercept form, just plug in where you start. If I plug in -1 plus 3, I'm going to get 2. So at -1, I know it's going to be up here at 2, and it's going to be a filled-in circle. And then you just do your slope from that point. So there's no need to like have to go back and erase. Like just start at wherever you're supposed to start on the x-axis. And I was like, oh my gosh, that's genius. Then you don't have to erase. It happened once in pre-calculus, because we do piecewise functions in pre-calculus, because like I started at the y-axis, but I really needed way over here, so I just kept like going over with my slope, and then they said, well, that's a waste of time. So then I would do my slope, and I'm going to go down 1, back 1, down 1, back 1, right? I just like to make lots of points. So I'm going to put an arrow on it to show that it goes down forever. But you could see if you went up 1 over 1, you would get that y-intercept of 3. So notice the piece in the middle does not have arrows on it because it does not keep going. It stops between -1 and 1, but the ones on the end keep going forever in the left or the right. Questions on where I got at? Think about the domain and the range. The domain. If all my pieces over here stop where 1 starts, the domain is all real numbers. Is my domain all real numbers? -1 to -1, 1 to 1. All the x's are used. This is one of the examples I was saying that the range is really tricky on this. Are we going to negative infinity with the y's? Are we going to positive infinity? Or we're definitely going to negative infinity because this is going down forever. And it comes up, and where does it stop on this first 2 lines here? It stops right here at y equals 2. Do you see that? So I have to stop my interval there at 2, including 2, not including 2. Because even though this one's not included, that one is included. But then we have another y value that's used, right? What's the other y value that's used in this problem? 4. Is 3 used? Is anything between 2 and 4 used? Is anything after 4 used? No, it's just the number 4. So to write that in your range, you're just going to put like comma, and you're just going to write the number 4. Like we can't write an interval when it's just a number, so I always put like the braces around it. Like it's everything from negative infinity to 2, including 2, and then also we're using number 4. And that's where ranges can get a little crazy on piecewise functions. Questions about that? Piecewise, because they're in pieces and you got to be wise to do it. Yeah. Yes. Okay, so I got one more that's not on here because I didn't want to waste paper. But what if I went backwards, and what if I gave you a graph and I asked you to write the function down? I'll put it on classroom here. So one thing you have to think about when you're writing a piecewise function is that you have your equations here, but you have your like restricted domains over here. What's the point that the x is changing on this graph? Like what would be my dotted line on this graph? X is 2, right? So one of them is going to be less than 2, one of them is going to be greater than 2. Yes? So that's this part. So I have x is, this side would be less than, right? Say less than 2. And then this side, because it's filled in, I think I heard Chandler say, would be greater than or equal to 2. So I got that part. Which one looks easier to write the equation for? This one or this one? This one is these are my favorite ones because we've done it twice already. When it's just a horizontal line, it's just one number, right? What number is that going to be? It's the y value where that is, right? And so that's y equals 1 with a slope of 0. So it's just the number 1. Which part's that going to go on? The top or the bottom? Because it's greater than? It's just the number 1. What about this guy? Chandler, what do you think? You change your answer, Chandler? Minus 4. Slope-intercept form, kids. Y equals mx plus b. This is my y-intercept. Negative 1, 2, 3, 4. This is my slope. Oh, I think I still disagree, Chandler. Up 1 over 1, up 1 over 1. Is that a slope of negative 1? That's a positive slope, isn't it? I know, but when you do negative slope, it's like if you were walking on that, going uphill, right? Like imagine continuing it as a positive slope. It's always left to right. Like it's always if you did it right to left, you would be going down, right? But it's the way you read it. So if you're thinking about up is positive and down is negative, you put your little guy on the left side of your graph. Uphill. It's a positive slope because I'm going up 1 over right 1. So that would be positive x minus 4, not negative. Don't we read left to right? But it's not. That's reading backwards. Here we go. Let's play it. This is a positive slope because if you go left to right, it looks like it's going up, right? It's increasing. Because if you put your little guy here, he's walking uphill. Left to right, so this is positive slope. But left to right, you put your guy on the left side of the graph, just like if you were reading to the left. This guy's walking downhill, so this is a negative slope. It's all about increasing and decreasing is what it is, but you start from the left to the right. Okay? That's why if you have a 0 slope, it looks like this. Put your guy on here, he's not walking uphill or downhill, he's just walking flat. That's 0 slope. Undefined slope. It's because you can't put the guy on the line, he would die. It's undefined. You can't draw, you can't ride on, you can't walk on that one. Okay? Chandler, please shut up. Oh! So you have to recognize positive slopes, negative slopes, or be able to count. And if I go up positive 1, I go right positive 1. Positive over a positive is a positive. It's supposed to be shortcut to think about like uphill and downhill. And if you get confused by that, then you have to just count. Okay, here we go. So, for once in your life in here, you actually have some time to work. This homework should look really, really familiar to the questions that we just did on the note. This is what I try to do every day in here. So the first 2 questions are just like our first example, where you're just thinking about which piece I use. You should just get one number for each of those. And then I gave you two problems to graph, and you have to get a domain range with them. And then on the back, look at that, right on the back. Notice that on number 5, all they want you to do is give the integrals to the domain, which means they just want you to do this part, right? That's not hard to do. Think about what would the x be restricted between? And then I added an extra credit part and you would write the equation for the piecewise function and the domain range for that. But just all you have to do is talk about the restrictions and x restrictions. You have like 15 minutes, so everybody needs to be working. You do get participation once in here.